Okay, so here's F and here's G, and this is a free response on the Math 3 Honors Test Review 1. Okay, using interval notation, identify the domain of both functions. So the domain are all the x values that you can plug in. So here on this first function, what's the smallest x value you see here? -4. Does it go to negative infinity on this one? No. So it starts at -4. And is that -4 included or not included? And you get that answer from here. So it doesn't have the line underneath it, so we're not going to include it. So this symbol matches the parenthesis, okay? Not the bracket. If it had the line underneath it, we'd put the bracket. So now we go, okay, the x's then go to -2, and that's equal to -2. And then -2, then it jumps down here, and this says all the x's greater than -2. Okay, so if it went from equals to -2 to greater than -2, then is -2 included in the domain? Yeah, it's included in this one here. Okay, now this says all the x's greater than -2, which means we're going towards what? That's going to be towards positive infinity. Okay, and positive infinity is never included, it's always a parenthesis. So that's the domain of f, from -4 all the way to positive infinity. Okay, let's look at, do you know what would be helpful is maybe write the domain of each piece. So what's this domain? All the x's less than -4. That's going to be from negative infinity to -4. And is -4 included? Nope. So it's going to be parenthesis. And then this line, these are both lines, this line says all the x's greater than -4, which means we start at -4 and go towards positive infinity. Okay, is -4 included in either one? No. So the domain of G is from negative infinity to -4, unioned with -4 to positive infinity. And you guys see that's where we're like jumping over, we're skipping over the -4. Okay, find the values of f of -2. Okay, f of -2, you guys, you can only plug it into the piece where f is equal to -2. So you have to look at f and go, am I going to plug that into the top or the bottom piece based on over here on the right-hand side? So -2, is that in the top piece or in the bottom piece? Do you see how this says a little equal sign? So we can only plug it into the top piece here. So we're going to take -2 and plug it in for the x values. We can't plug it in the bottom because it's not defined there. It's -2. This is for x is greater than -2, like -1, 0, 1, 2, like that. Okay, simplify this. -2 squared is a positive 4. -2 means plus 2. Plus 2. What's half of 4? 2. 2 plus 2 plus 2 equals 6. So that's one of the answers there. Find the values of f of -2. Okay, anytime we're doing like a multi-part problem, your work has to be organized. So I just drew that line to say, okay, I'm done with this one. Now I'm going to work on this one. Do I worry about the G first? What do we do first? Inside first. Everyone say inside first. Inside first. Okay, so f of 3. Now, a piecewise function, you don't start on the left here, you guys. You have to start on the right. Which piece am I allowed to put x equals 3 into? I can't, the top one is only from -4 to -2, and this is a +3. So I can't plug it in the top one. If you did that, just cross it off. It's not defined at 3. Only the bottom one is defined at x equals 3. Okay? So we're going to plug 3 into the bottom. All right, quickly, what's 3 plus 6? 9. Do we know the square root of 9? 3. 3 plus 4? 7. Are we done? No. So we're supposed to take f of 3, which is 7, and plug it into the g function. Now, g is also a piecewise function, so you need to make sure you plug it into the correct piece. So 7 is 7 less than 4, -4, or is it greater than -4? Greater than -4, so we're going to plug it into the bottom piece. Again, if you plugged it into both of them, you can't do that. You only plug it into one piece. All right, -1/2 times 7 is -7 over 2. What's another way to write -7 over 2? Yeah, -3.5. Okay. Either way is fine. They both mean the same thing. Okay, is f continuous at -2? This is a yes or no answer. We know it's defined at -2, but is it continuous? So f will be continuous if both pieces connect, which means they have the same y value. Didn't we already plug in -2 into one of the pieces? Yeah, we already plugged it in and we got 6 when we plug it into the top piece. So we're going to plug it into the bottom piece. So f of -2. Okay, I'm going to erase this because I really can't say that it's equal. There's a hole and we're going to see the height of the hole. So -2 plus 6 plus 4. Okay, what's -2 plus 6? 4. What's the square root of 4? And then 2 plus 4 is 6. Okay, so there's a hole is at 6 and the point is at 6. So if the point is at 6 and then the hole is at 6, do the pieces connect? Yeah, so if the pieces connect because they have the same y value, then is f continuous? Yes, here's an example where you can't just leave the math and leave the question. You have to actually answer the question. So the question says, is f continuous at x equals -2? And you need to declare to the world, yes, f is continuous. I feel like I did something wrong. OUS. F is continuous at x equals -2 because the two pieces have the same y value. Ta-da! Okay, let's finish D. Is G continuous at -4? Now, one student who's kind of zoned out and just copying and not really paying attention, you would probably just plug in -4 into both pieces on G to see if they're equal or not, right? Because that's what we just did here, right? But there's a big but on G. G has 2 holes, correct? Here, I'm going to zoom back down. This is a hole and this is a hole. So even if the holes were at the same spot, would it be continuous? No, because there's a hole. What's missing? Yeah, there's no y value at -4 at all. So is G continuous at x equals -4? No, we already said that -4 is not in the domain. Is not in the domain. So it doesn't matter. I mean, if you want to do more math, you can figure out if the 2 holes are at the same height, that's different, or if they're at different heights, like that. But it doesn't matter if the pieces connect or don't connect because -4 was not in the domain. All right.